Okay, this is the notes and the warm-up for the first unit of parallel and perpendicular lines. This is a jury duty summons. It's why I'm not here with you today. So, this is a pre-assessment, and we just want to get a sense of what you guys know and what you don't know coming into this unit. In addition to doing parallel and perpendicular lines, we're also going to be talking about angle relationships. So how could you properly describe angles 1 and 2? You have several options here. Supplementary. Those are also adjacent angles. And they also form a linear pair. Angles 3 and 8, you could reason that those are supplementary angles. And we will talk about how we know that to be true later on in the unit. Angles 2 and 7 are known to be congruent angles. To some extent, they look like they have the same measure. So maybe that can point you in the right direction. And angles 1 and 4, this angle relationship, this special relationship is called vertical angles. So we're going to learn all about these as we go through the unit. And then we've got parallel and perpendicular lines. And anytime the slope is the same, we know we are dealing with parallel lines. And anytime the slopes are opposite reciprocals, we know we are dealing with perpendicular lines. And then the other two cases here, these are neither parallel nor perpendicular. And we will talk about recognizing that right now. So going into the first page of the notes, here you've got an example of parallel lines. They are not intersecting and they have the same slope, and you can see that in the equation here, 2/3, 2/3. The slope is the same, but the y-intercepts are different. Slope is the same, y-intercepts are different. Slope is the same, y-intercepts are different. Slope is the same, y-intercepts are different. So parallel lines have, let's say, equivalent slopes. And then intersecting lines, all lines are either parallel or intersecting, and sometimes that intersection is perpendicular. But intersecting lines will just have different slopes. Or this is a special case here. Well, here the slopes are the same, but the y-intercepts are the same also, so it's really the same line on top of itself. So if you were to graph 5x plus 2, it looks something like that, and then if you graph it again, it's just the same line right on top, so it's intersecting at every single point. Generally speaking, intersecting lines will have different slopes. And then perpendicular, as I said, is a special case of intersecting lines. Perpendicular lines have opposite reciprocal slopes. So you can see that if the slope was 2/3, the reciprocal of 2/3 is 3/2. We just switched the numerator and denominator. And then the opposite of that made it negative 3/2. Here, -5, the reciprocal of 5 is 1/5. And the opposite of negative is positive. So we have opposite reciprocal slopes. 1 is the fraction 1/1, and of course if you take the reciprocal of that, it's still 1. And put the negative in front because it's opposite reciprocals. And in this case it's a little less obvious. For x equals, those are horizontal lines with slope equals 0. Y equals, slope is undefined. And those are considered to be reciprocals as well, and it really makes sense. Horizontal line, vertical line, at x equals 3, y equals 2, that's going to make a right angle when horizontal and vertical intersect. So in general, perpendicular lines have opposite reciprocal slopes. And it is parallel and perpendicular lines and slopes that we're going to focus on today. We're going to need our slope formula, and that is y2 minus y1 over x2 minus x1, vertical change divided by horizontal change. And we're just going to graph some parallel and perpendicular lines, starting with this one right here. So the first step is to graph the line y equals 2/3 x plus 4. Our y-intercept is 4, and our slope is 2/3. So from here you count up 1, 2, and over to the right 3, up 2, over 3, and you can continue that pattern. Notice how all the points are in a straight line, and to keep going backwards we could go down 2 and back to the left 3, down 2, back to the left 3. This way we can complete our line. So this is the line y equals 2/3 plus 4. And we're going to draw lines parallel to that line and perpendicular to that line. And so the slope here is 2/3, which means the slope of any line parallel to this given line here will also have a slope of 2/3. Y-intercept isn't really important right now, it's just that it's parallel, so let's go ahead and use the origin. And we could pick any point, and as long as from that point we counted up 2 over 3, up 2 over 3, up 2 over 3, and gave it the same slope, or we went back 3, down 2, back 3, down 2, down 2, back 3, that gives us the same point. So this line here is parallel to the given line, and like I said, it really doesn't matter where we start. We could pick this point right here, and as long as we went up 2 over 3, or down 2, back 3, down 2, back 3, even though the y-intercept is on a fraction there, all three of those lines are parallel because they have the same slope. And we can do something similar for perpendicular lines. We just need the opposite reciprocal of 2/3. So reciprocal means invert the fraction or switch the numerator and denominator, and opposite just makes positive becomes negative or negative becomes positive. And now we can pick any point and use that opposite reciprocal slope to graph a perpendicular line. So let's start from the origin again and go down 3 over 2, down 3 over 2, down 3 over 2, down 3 over 2. Or we can go up 3 and back to the left 2, up 3, back to the left 2, left 2, up 3. And we connect all those dots right there, and what we've got is a line that is perpendicular to all three of the parallel lines that we drew. So it's a 90-degree angle, 90-degree angle, 90-degree angle. And again, we don't have to choose an origin. We can pick any point we want on the graph. Let's say we started right here. As long as we use this opposite reciprocal slope and go down 3 over 2, down 3 over 2, or up 3, back to the left 2, up 3, back to the left 2, up 3, to the left 2, and we connect all those dots. We've created another line that is perpendicular to all of the three parallel lines that we just drew. And then of course, because the two perpendicular lines have the same slope, these two lines are parallel to each other but perpendicular to these three lines. So that is the basic idea of the lesson. We're going to take one line and we're going to figure out how to draw a line parallel to that line or perpendicular to that line. So I'll give you a moment. You could maybe pause the video if students need a chance to catch up, and otherwise we will move forward. And we're going to remove things from the graph for a little bit. This question, what is the parallel postulate? This is important, but we're going to come back to it another day. What is the point-slope equation of a line? That's what we're going to need in order to do our parallel and perpendicular lines. So that is y minus y1 equals slope times x minus x1. And x1, y1 is just a point, and the slope is given to us one way or another. So in this example, we're just going to do the equation. We're not going to do the graphing. But we will come back to connecting it to the graph in a separate lesson, because I think that's important. So what is the equation of a line passing through 3, 2 and parallel to the line y equals 2/3? So there's a little process here I've given you. You don't have to use it. If you're quick with the algebra, you should be able to jump to step 3 pretty quickly. But the given slope is 2/3. We're asked for a slope that's parallel, so the slope of our new line is also going to be 2/3. And then we want it to pass through this point right here. So we're going to use the parallel slope, which is equivalent to the original slope, and the point 3, 2 in order to write the point-slope equation of our line and then convert that into slope-intercept form. So y minus y1 is 2 equals the slope of 2/3 times x minus x1 is 3. So writing the point-slope equation is pretty easy. Converting to slope-intercept form takes a little bit more work. Again, you've sort of got to be good at algebra to make it happen. But we want to get to y equals mx plus b. So take y minus 2. My first step is to distribute. And then this is where 2/3 times -3. Let's look at that off to the side here. That's the same as 2/3 times -3 over 1. So the 3's are going to cancel and just leave us with -2. And then we can add 2 to both sides. Y equals 2/3 x plus 0, or just y equals 2/3 x. So the slope of the line parallel to this line here, but passing through the point 3, 2, is just 2/3 x with a y-intercept of 0. And now we'll follow the exact same process, but we're going to do a perpendicular line. So the equation of the line passing through this point, so this is our x1, y1, but perpendicular to the line 4x plus 1. The only thing we need from this line is the slope. The given slope is 4. Since it's perpendicular, the opposite reciprocal slope will be -1/4. And then we'll use point-slope equation to write the equation of the line. Y minus y1, which is 1, equals our new slope, -1/4, times x minus x1, which is -2. So minus -2 would really become +2. So that's x plus 2. And then you've got the point-slope equation. So if you can get that far, that's good. But now we want to convert it to slope-intercept form. So we'll start by distributing the the -1/4, I mean. -1/4 times 2 is -1/2, or -0.5. And if we add 1 to both sides, we're going to end up with y equals -1/4 x plus 1/2, because -1/2 plus 1 whole is 1/2. And you could use -0.25 and 0.5 if you prefer decimals. It's okay with me. And then we could go take the next step and put that line on the graph, which again is something we're going to come back to in another lesson, so you can better visualize what's going on. Again, you can pause the video for a moment if students need a chance to catch up. Otherwise, you should definitely, at this point, we do want to pause the video for sure, so that everyone can have a chance to practice what we just did on their own. So parallel is going to follow this model. The only thing that's different is the details and the numbers of the algebra. And then the perpendicular one, you've got a model for that as well. And it might help to rewrite your point slope equation so you've got it on the same page. And then pause the video for 5 to 10 minutes, however long it takes students to complete these two problems on their own. And then once everybody is finished, unpause the video. So let's go ahead. I hope you had a chance to work on these. Here is what they should look like. The slope of the given line here is 3. Since we're dealing with parallel, our parallel slope is also 3. And point slope equation should look like y minus, let's see, y1 is negative 3, so that's going to be y plus 3 equals slope times, so our slope is 3 times x minus x1, and then we just convert that to slope-intercept form by distributing the 3 and then subtracting 3 from both sides to get 3x minus 6. So there's your point slope equation, and there's your slope-intercept equation for the line parallel but passing through this point. And now we'll do the same thing here, except this time we're talking about a perpendicular line. So the given slope is negative 3/4. The opposite reciprocal will be positive 4/3. What is the equation of the new line in point slope form? So y minus y1 equals the slope 4/3 times x minus x1. And then we would convert to slope-intercept form, and this one is a little bit challenging because of the fractions. Negative 8/3, we add 5 to both sides, and we are stuck having to do negative 8/3 plus 5, but you can write 5 as 15/3. Now they have the same denominator, so y equals 4/3 x plus 7/3. For the most part, I've tried to steer clear of examples that involve adding fractions like this, but sometimes it does come up. Okay, we're going to skip this for the moment, and let's do one where we put it all together and we do have the visual piece back in place. So if we graph the line y equals 1/3 x plus 3, go to the y-intercept of 3, up 1/3, up 1/3, up 1/3, down 1, back 3, down 1, back 3, down 1, back 3. And we sketch in our line there. And we want to graph the point 3, 1. So we're going to do a line parallel to this line, but passing through this point specifically, and then a line perpendicular to this line, also passing through this point specifically. And the visual piece is going to make things easier because you can just, well, I know I'm going to use the same slope for the parallel line. So you can just add in the points and do it all completely visually. And you should be able to see that the y-intercept is 0 there. Nonetheless, let's go ahead and do the point slope equation. So if we're passing through this point and using a slope parallel to 1/3, we're going to do y minus y1 equals our parallel slope times x minus x1. And then if we were to convert this to slope-intercept form, we would get the equation of that line. Y minus 1 equals 1/3 x minus 1, because 1/3 times negative 3 is negative 1. Add 1 to both sides, and we get y equals 1/3 x. So you can see our parallel slope and our y-intercept is 0. So our equation matches our picture. And then same thing here, but now with a perpendicular slope. So perpendicular to 1/3, but passing through this point. So we just start from here, and instead of 1/3, we use negative 3, because that's the opposite reciprocal. And that would be down 3 over 1, down 3 over 1, down 3 over 1, or up 3 back to the left 1. 3 back to the left 1. And we sketch in the perpendicular line. Okay. And now it looks like our y-intercept is going to be 10 from the picture, but let's go ahead and use the point slope form to be sure that that's true. Y minus y1 equals our opposite reciprocal slope times x minus x1, and then we get y minus 1 equals negative 3x plus 9. Negative 3 times negative 3 is plus 9. Add 1 to both sides, and sure enough, we've got our perpendicular slope and our y-intercept of 10. So that does it for notes. This assignment is due on Kia. I'm not going to make it due Friday. Let's make it due Sunday, November, let's see, 2nd was Friday, 3rd, 4th by midnight. So you're going to have 2 Kia assignments this week, both of them due Sunday by midnight. And this page right here, this first page, is from the page that we skipped, but I will come back and do that with you guys on another day. This is the page that you should be working on. And so spend 15, 20, maybe a little bit more, 25 minutes working on these problems, writing equations in slope-intercept form. So you're just going to follow this exact same method that we practiced in the notes on these 8 problems. And our goal is to have the slope-intercept form of the equation for each of these lines.